Okay, so to start with, we just multiplied out something that had been factored, and now it's not factored anymore. Now it's standard form. Standard form, at least I have the y-intercept over here. And don't forget that the original, that was in factored form, I could get the roots really easy. That one would be -1. This one, I'd have to set 2x minus 3 equal to 0. 2x equals 3. X equals 3 over 2. Just a quick reminder that those would be my zeros for this equation. The x-intercepts. That's the y-intercept. All right, so why'd we just do that? Because now we're going to say factor that. And I know it's kind of a dumb question because we already just saw it 2 seconds ago. But imagine for a moment, and everybody set up 2 sets of parentheses, and I'll talk you through how we would get this answer. All right, let's go with Vikram. Can you tell me what you would know would have to be here and here, the 2 red circles? Yes, there definitely has to be an x in both of them, but does x times x make 2x squared? No. So what else has to be there? 2. Yes. So notice you start with something that gives you the first term. In this case, that's 2x and x. Now, same rules on this next part. Because this is a -3, we know ahead of time that these 2 signs cannot be plus and plus or minus and minus. There has to be 1 plus and 1 minus. But do we know where it is? No, we don't. So all you do is you just take a guess and say, I think it may be going to be plus first and then a minus. Might those have to be switched around later? Yes, they might. Okay, and then last but not least, these 2 numbers that I'm circling in green have to be 3 and 1. That's the only 2 numbers that make 3, is 3 times 1. Now, where should they be? I don't know, but I'm just going to take a guess. And I'm going to show you how you piece it together, because you're going to guess wrong a lot. All right, so I'm going to try putting a 3 here and a 1 here. Now, I'm going to see what happens. What parts do I need to check? You could check all of it, but especially the smiley face of factoring. And this is why we don't use that any fancy rule. There is ways to do this that are fancy, but they're much more complicated than this. All we got to do is check it and see if it worked. And if it doesn't work, make smart adjustments. All right. Matilda, can you tell me what the outside part of the smiley face makes? This part. Could you say what you said again?
Oh, it'd be -2x.
Okay, and then the inside part?
It'd just be x.
Yep, and I'm going to ask you to say positive 3x because the negative and positive matter so much here. Okay, so now I'm going to put them together. I get 3x and -2x, and together they make x. And a lot of people think, sweet, we did it right, but we didn't. Martina, what's wrong with x as my middle term?
It doesn't, like, if you add x and then subtract 2x, it doesn't make the middle one.
Yes, what is the middle one? Negative x, and we wanted it to be negative x, but he got positive x. Now, whenever you get the exact opposite of what you wanted, then you got to switch and go, oh, the signs are wrong. Opposite answer means you got to use the opposite signs. I used plus and then minus. I got to change it to minus and then plus. How do you know not to move the numbers around? Because if the numbers need to be moved around, the answer will be way off. Instead of opposite of what we want, the number would have been way off. Let me show you what I mean. Let's say we'd have put a 1 in the first spot and a 3 in the last spot. Let me just show you, because this is going to happen a lot. You got to be smart about how to switch the numbers around here. Outside, inside. 6x, negative 1x. That makes 5x. Is that even close to what I wanted? No, it's not even close to what I wanted. So since it's not even close to what I wanted, I got to switch the numbers, not the signs. So please listen to that carefully. I'm going to say it one more time. If you multiply it out and you get the exact opposite of what you wanted, you switch the signs. If you're way off, you switch the numbers. That will work every time. Okay? If you're way off, switch the numbers around. If you're only off because it's opposite of what you want, switch the signs. All right, let's see if you have learned anything. So here's our first slide about what this is. It says A is not equal to 1. What is that even talking about? Well, that's because technically that is the form of a, well, these are parabolas, but of a quadratic, okay, where the function has an A in the front. If A is not a 1, if it's anything else, if it's like a negative, if it's like a 2, or if it's a negative 2, if it's anything there, if there's anything there at all that's not a 1, then we have to use this special way of factoring it. All right, so this is something that I have already explained, and I think it's just going to confuse you more. So I'm going to move on. And let's try factoring this one. All right, so remember there's 3 little parts. What comes first? What are the signs that are in the middle? And then what goes last, which is the numbers that are at the end. All right, let's go to Bertha. Can you tell me what, see those blue arrows in the front? What has to be in the front?
The 3x distributed into the 2 parentheses.
Okay, so what'll it be?
The first one could be 3x, and then the second one could just be x.
Perfect. That is exactly it. Dallin Thomas, can you figure out for us whether we need to have a minus and a minus, a plus and a minus, or a plus and a plus? Or a minus and a minus?
Would it be a plus and a plus?
But then you wouldn't get negative 10 at the end.
Plus and a minus.
There you go. Plus and a minus. All right. Next up, Veda. Give me some numbers that multiply to 10. And I know there's more than one choice. Just anything that multiplies to 10.
1, 2.
All right. Now you get to pick. If you go and slap it in here in your head right away, I want you to think quick. It's going to make a 15. Do I really want it to make a 15 so that I have an answer of x at the end? No, that's probably not smart. That's what your brain's going to have to do, is go, okay, the 5 definitely can't be there because there's no way that it would total up to x at the end. So then I'm thinking the 5 maybe here. Okay, and then the 2 here. Now everybody check the smiley face of factoring and see what you get. Bennett Worry, what do you get on the outside ones? The black line that goes between the 3x and the 2.
Is it negative 6?
Perfect. And then the inside one?
Is 5x?
Yep. When you put them together, what do you get? Be careful with the sign. Is it negative or positive?
Negative.
It's negative what?
Negative 1.
Negative 1 what?
X.
X. All right, negative 1x. So if it's negative 1x, is that exactly what I wanted?
No.
No, because I wanted positive x. So do I just throw everything out? No. If you ever get the exact opposite of what you wanted, you're super close. Victoria, can you tell us what to do? We got the exact opposite.
Would you switch the 5 and the 2?
Nope. Because if it had been way off, I would switch the numbers. I'm going to write this down. If it's way off, switch numbers. If it's opposite of, switch signs. You know, there's a plus and a minus, and there's a 5 and a 2. And there are 4 separate pieces to this puzzle. A plus and a minus and a 2. I said 4, I think. And a 5 and a 2. Plus and minus and 5 and 2. And I got the exact opposite of what I wanted. Martina, what do you think we should do?
Make the +5 -5.
Yes, so switching the signs. I'm going to change this plus to a minus and this minus to a plus. That is the little puzzle, and I know it's going to work now, but I suppose I should just check. Negative 5x on the inside, and then the outside I get positive 6x, and then when I put these together, I get the positive x that I wanted, and yay, I know it works. One of the things that's cool about this unit is on this test, you can take your answers, multiply them out, and they either work or they don't. And you'll know if you're right. So you might even end the test with one you just can't figure out, but you'll know that it works or it doesn't by multiplying it back out. That's why we started with one of those on the first slide. All right, next one. Everybody try factoring this one. Be ready to be called upon, no matter whether you're at home or at school. Angelina Fisher, tell me how you think we should start. I know you're not done, but how do we start?
You put 2x.
Perfect. And how about in the other one?
2x.
If I do that, I will get 4x squared. So got to change that.
Just x.
Yep, there it is. Nice job. Okay, and the way I knew that wasn't going to work is because I multiplied it back out to check myself. That's what you're going to do a ton of, is you multiply it back out and go, oops, that didn't work. It's going to happen over and over. It's called guess and check. But man, if you get good at this, it's just grinding it out then. It's not hard. It's just like, okay, does this times this equal that? And you're going to be sitting at home with a calculator, so it's totally okay for you to go, okay. You can't multiply the x's, of course, but the 2 times the 1. Oh, wait a minute. 2 times 2 makes 4. It doesn't make 2. All right. Luke Scrivseth, the signs. Signs. Everywhere are signs.
It's going to be a negative and a positive.
You are correct, sir. No, wait a minute. I know why you said that, because there's a negative on the inside. But a negative and a positive would not make a positive 5 at the end.
Right, so yeah, the negative.
Yes. They both have to be negative. Good job. Let's go to Amelia. We made this one easy on the 5. There's really only 2 things. How do we end? I'm not sure where they go, but what are the 2 numbers, Amelia?
I don't know. I can't figure it out. I'm sorry.
Okay, I'm feeling, just watch. 2 things that multiply to 5. I don't think you are thinking the right thing. Yeah, it's got to be 5 and 1. All right. So I'll come back to you in a minute. If I do 5 and 1, we're going to have, who's going to step in and save the day? Javon, tell me where to put the 5 and the 1, and it doesn't even matter if you're wrong. We'll check it. All right. And now we check it. Everybody take a second and multiply this sucker out with the smiley face of factoring. Joe Larson, what does the outside loop make this one?
Would that be 10x?
Yep. And what does the inside loop make?
1x. Or negative 1x.
Yes, negative 1x. Put them together. Are they like the right number but the opposite sign? No. These make 9x. That's not the same as negative 7. That's not even close. 9 and negative 7 are not even close. That means, do you just switch the signs around? No, that can't work. Lily Studensky, what should I do? Now that I know this is wrong, do I switch the numbers around or switch the signs around, Lily?
In this case, you'd have to put the 5 with the 2x.
All right, so we're going to switch the numbers around. Remember, if you'd have just been like the opposite of what you wanted, then we would have switched the signs. But we were not even close. Now we can double check it. And we can leave those same loops there. And now we can see what we get now. Cameron Thompson, the 2x times the negative 1, the outside loops, this part.
2x.
Close, there's a negative 1.
Oh, negative 2x.
Okay, and then the negative 5 times the x, the inside part.
Negative 5x.
Perfect. Now, do they total up together to negative 7x?
Yeah.
Yeah, they do. So then we got it. That's got to be it. Because if the smiley face to factoring works out, you should have a smile on your face because it worked and you're done and you know you're right. Put your virtual hand up if you had that answer before I finished it. Like you had it and you were just kind of waiting on me to finish. All right, it's about half of you. All right, I know this is tough, but we got to get that up to like at least 3/4 of you. Let's try another one. Now, what's the difference between this and this? This side says solve. That means when it is factored, you set your little factors equal to 0. So it's the same exact problem. Factoring it is the really hard part. The other part, super easy. So let's do the factoring part. 2 sets of parens. And Matilda, how do I start them? The numbers in the front of the parentheses.
You do 5x and then x.
You got it. And let's go with, oh, haven't I even called on? I think I called on almost everybody, which is awesome. Jack Lewinsky. Tell me, is it plus and minus and minus, or minus and plus, or plus and plus?
Wouldn't it be minus and minus?
Tell me why. You're right, but some kids won't know why.
Because it's a positive 6 and 2 negatives equal positive.
Yep, and why are you using negatives at all? You knew to use negatives because what?
Wait, can you repeat that?
Sure. You knew to use negatives. See, some kids are going to go, why don't you use plus and plus then? Because plus and plus will make a plus 6.
Well, that wouldn't negative 13. I would mess with that.
There you go. It wouldn't give you a negative 13 if we used a plus and a plus. All right, perfect. And then, Jack, just finish it off. What do you think the 6, is it a 6 and a 1, or do you think it's a 2 and a 3? And I don't know either, but give me your best guess.
6 and a 1.
All right. And best guess, do you think the 6 should be first or second?
First.
All right. 6 goes here, 1 goes here. And I agree that's a really good guess. So what do? We check it with the smiley face of factory. Everybody be ready to be called upon, but do it yourself. Okay. Are we even close? You should have got negative 5x, and we got negative 6x. And negative 6 and negative 5 make negative 11. Dang, we are kind of close. But if we just switch the signs, it's just going to make it positive 11, which still wouldn't be close. So I'm not switching the signs because I would just get the opposite number. So I don't switch the signs. I got to switch the numbers. So now I'm going to switch the numbers. We'll try the 1 first and the 6 second. But wait, that's going to make negative 30. Okay, this isn't working. Now what do I do? Because this is coming out to negative 30x, and you're not going to be able to put that with something and make 13. So I switched them. It still didn't work. Cameron, do you know what to do? It can't be 6 and 1.
It was glitching out. Sorry, what?
It can't be 6 and 1. So what do you think it should be? The numbers that are here and here, they can't be 6 and 1. We just tried that. So I'll come back to you, Cameron. Alex Stone.
Okay.
Okay, where do you think the 2 should go? It's a 2 and a 3 makes a 6. You're right about that.
The 3's with the 5x.
All right. So I'll try the 3 in here. And the 2 here. I think it's going to work because I did it in my head quick. If you start realizing how to check these and you go, in your head, you just go, oh, that makes negative 10, that makes negative 3. You'll be able to do these really quick and you'll be like, oh, yep, it worked. Sweet, I got negative 13. That's what I wanted. I'm done. And then over here, you just have to do these two little equations. What are these? These are from inside here. And you set them equal to 0. Oops, minus 3 there. Sorry. Just copying here. And then 5x equals 3. X equals 3/5. X equals 2. Those are the solutions. The roots, the x-intercepts, the zeros. There's 4 things they're called. Solutions, x-intercepts, roots, zeros. So you just take your 2 little parentheses and set them equal to 0. All right, let's try one more here. This one, look at the red exclamations. GCF warning. Jack, help me out. What the heck does that mean about the GCF?
Greatest common factor, so you would pull that from those numbers.
What do you think goes into 12, 22, and 4?
2.
You are correct, sir. 2 comes out. Everybody, don't try to do 2 parentheses here. Just one set of parentheses. Just divide everything by 2. Cameron Thompson, dividing everything by 2.
6 and then 11 and then 2.
6 and then 11 and then 2, except it's negative 2. But yes, there you go. Good job. Nathan Vikram, or Vikram Nathan, sorry. Do you think I can just quit here and be done?
No.
No, because I got to factor it again. Give me your best guess on what to put here. I'm going to circle in green, and here.
6x and x.
That's my best guess. But are you aware that there is another choice?
Yeah.
What is it?
Uh,
Another way to make 6x.
2 and 3.
Yeah. I could have put 2x and 3x. So how do you know which one it is? You just try it. All right, Lily Studensky. Should I use a plus and a plus, or a minus and a minus, or a plus and a minus?
A plus and a minus.
Excellent. And then what? You got the easy one, Lily, so why don't you tell me the other easy one? What multiplies to 2?
2 and 1.
Okay. Now we have a viable possibility. We don't know if it's going to work, though, until we check it. Now, I can tell you one reason it cannot work. Because right here, that could be factored again. They both have a 2 in them. And that can't happen because we already factored out the GCF. I know it's not going to work, but I'll prove it. That's a negative 6x and a positive 2x. And that definitely does not make a 22. It's not even close. So then I go, okay, if it's not even close, I got to switch the numbers. Can't be a 1 there and a 2 there. It could be a 1 here and a 2 here. Now could it make maybe work? Well, I get negative 12 and positive 1, and that doesn't even close to make 22 either. I just tried all the possibilities. No, I didn't. Because I could switch that 5 or the 6x and the x into a 2x and a 3x. And now I'll give everybody this hint. The numbers that are circled in green are right. You figure out what the final right answer is. You got to just switch around the 1 and the 2 until you finally get it. And if you're like, but I'm not getting it, Mr. Surver, maybe it's impossible. Are there things that are impossible to factor? Yep, there are. That's negative 4x. That's positive 3x. That makes a negative x in the middle. And that's not an 11. Wait a minute, an 11? I was looking at this 22 the whole time. Holy crap. I just realized I just made a mistake. One of the other answers we had was right, and I passed it over. I don't know if anybody saw that, but you just witnessed your teacher screwing up his factoring. Because I was trying to make it equal 22, and it actually is supposed to equal 11. So, sorry. It should have been a 6x and an x. And then I'm really close. Sorry about that. Making an adjustment here. Can anybody tell me what the final actual right answer is? Because I'm close now. I was trying to make it make 22, and it doesn't make 22. It makes 11. Jack Lewinsky, what do you think the final answer is? I'm close, but I haven't quite got it yet. How about this? Multiply this one out for me that I have. 6x times the negative 2, what's that make?
Negative 12x.
And the inside ones?
Positive 1x, so it would be negative 11.
And is negative 11 what we wanted?
No.
No, we wanted positive 11. So what do you do?
Flip the signs.
There it is. So instead of plus 1, I make that minus 1. So the minus is in front. And the plus is here. Whoa, that one was hard. And I know. I think a lot of you guys, I mean, I even made a mistake in it. I think a lot of you guys might not have gotten that one right on the test. Does that mean you're going to fail a test? No. If you can do the easier ones, the easiest ones, you get a C. If you can do a few of the medium ones, then you'll probably move up to a B. If you can do a really hard one like that, now you got a chance at an A. All right. One more. Sorry for the mistake on that one, but you know, I'm human. This one. Do you really think we'd make you do anything this hard? Yeah, we actually would. Because it's got a GCF that you can factor out. Once you take out the GCF that's in both numbers and you put it in front, this one really isn't that hard. Elisa, are you good at this? Like enough to know what goes into both of those two numbers? I know it's going to be hard for a lot of people. All right. I'm going to take a volunteer on this one. Does somebody see the number that goes into both of them? Bertha, what do you see?
3 goes into both of them.
You are correct. Everybody, now that you know 3 comes out, factor a 3 out. Martina, what do you say? After we divide both things by 3, what do you get?
X squared is 25.
Nice. Nick Richards. This is a pattern we learned over before the weekend. I don't know if you caught it. Do you remember this kind? We factor these are called perfect squares that are a difference because they're a minus, so difference of squares. Nick Richards, can you hear me?
Yeah, sorry, what?
So we're factoring the part that's underlined. Okay, Nick.
So would you put x?
Okay, good. And x to make an x squared, right? And do I need a minus minus or a plus and a minus or plus and a plus?
Plus and minus.
Perfect. And then there's not many things that make it 25.
Just 2 5s.
You got it. Now, how do I know that's right? Because I'm going to check the smiley face of factoring, and I get negative 5x and positive 5x, and they cancel out, and then there's no middle term, and that's what I wanted. So this is done. And everybody solve it then. And I'll call on somebody to give the answer, or two answers actually. Amelia, what are the final two answers to the solutions?
5 and -5.
You got it. So the solutions are 5 and -5, and the factoring was that. Okay, there. You've learned everything. So that's the lesson for today, including one mistake by me. But I think it's okay to see that because that kind of thing happens, and it can be very frustrating. You're going to do a lot of guessing and checking, and it's just not working. You rearrange things, and then maybe you realize, oh, I was multiplying it out to the wrong thing. So I do have a key for today that's going to be posted, but it's going to be posted after 3 o'clock because I don't want you to just go instantly look at the key, write down the answers. So I want you to try these in class, and then if you get stumped, you can go look at the key after school. All right, that's all I got for you for the video for today.